And I put some stuff out there, I know. And you should be able to see them now. Okay, there's that LinkedIn workshop coming up, right? And 11/16. Everybody should have a, did we talk about, I already talked about that, right? Maybe not. There's a LinkedIn workshop coming up, and you should be on LinkedIn. It's like an online profile of yourself. It's very large, it's very huge. This one guy started the company, then Microsoft bought it. And you want to have a profile set up before you go to the workshop, and they can kind of like give you some hints on how to make it stronger. I got mine. I'll show you mine real quick. And so am I. So here's me. I'm not going to go over the whole thing, but just to get an idea what it is, because I suspect some of you may not have it. And got advertisement there. Okay, so dang it. But the deal here is, you may meet somebody really briefly, and what you want to do, they'll say, what's your LinkedIn, that kind of stuff. That's me. I don't know what that is. Get rid of that. So it's like an online profile. So, and you get offered jobs for offer too. So I'm hooked up with 247 people, you know. So you guys kind of all know your stuff here. So you know, kind of all know your stuff here. So LinkedIn, like become, you know, kind of like contacts with each other. You know, I'll certainly endorse you for networking. I mean, I think you all know that pretty good. So you gotta have that as a skill. I'm really not looking at the, I want to show you my, view profile. Is it? They change this a lot too, so it kind of throws me off. This is not my profile, but anyway, it's out there, so you want to get that done.
Do you have your?
I don't want.
Sorry. Do you have your certificates listed?
Absolutely. Oh, absolutely. Yeah, sure. Put them all on there. That's a good place for it. That and the resume too. So, oh, here I am. Okay, so here's me. You know, CS instructor, was at IBM for a while, and then I went to school. Here's my certifications. You know, and Cisco instructor. Then I said show more, and I got some more stuff there. Cisco class. The CompTIA stuff to be there too. Yeah, CompTIA, right? We're gonna put all that on there, right? So if somebody sees that, they'll say, "Hey, hopefully this guy knows a little bit more," right? So I got some more there, Security Plus and everything. So you definitely want to put those on there, right? Absolutely, yeah. Then if you have volunteer experience, like student mentor, or you do something with like a church or a school or something, put that in there. Any kind of volunteer work at all. Employers like to see that. So Bessie Coleman, part of that too. So but then now I've got, well, usually I had some skills listed here, but you guys like, we get LinkedIn, then we become attached, you know, I don't have the word attached, but we're just linked in with each other, I guess is a phrase. And then then you put down some skills you think you're good at. And then I can go back in and say, oh yeah, he's good at networking, right? And I'll endorse you. And that looks good on your LinkedIn profile, right? So you want to have those skills listed too. And let me see if I can. It's a good thing to do. Now that's something else there. So, but now Rudy, you out there? I think Rudy actually had an appointment with our LinkedIn coordinator. And I don't know how'd that go, Rudy, okay? See if he's out there. Well, he was out there. I just see him come through the door. But anyway, you know, you can go through Julie McCarthy, and she'll actually work on you one-on-one. but you want to have something kind of set up first before you go in there. So just linkedin.com, and it's actually kind of intuitively obvious how you kind of set it up. If not, there's like little training videos, on YouTube and within LinkedIn. So, but anyway, that's LinkedIn. So I did have that as an announcement, and one more announcement. I think. Let me check. Then we'll get on to stuff. Oh, 10:03 already. Jeez. I'm just going back into this for today. Come on, system. Okay, LinkedIn workshop. Oh, I gave you that subnet. Yeah, subnet IP4 subnetting chart and the videos too. I hope you liked those videos. They were like really good. So I'll help you understand all this. So we're on IP version 6 today. And before we do that, we want to start out with one little more itsy bitsy review of IP4 because we got time to do that. And let's say I've got this subnet ID. Fix it for me. Subnet ID of 192.168.10.0, and I've got a subnet mask of 255.255.255.0. And also, we've seen some formulas in this class, right? We've got 2, and then we kind of go 2 to the subscript, superscript, 2 to the n. And we have another formula that is, get rid of that. It's 2 to the, go back to subscript. Oops. And I want to make sure we review these, then we're going to say farewell. 2 to the h minus 2. And I'll make it a little bigger so you can see it. Really, the question here is, what do those 2 formulas mean when it comes to subnetting? And we're going to start in the middle. So I think I saw Costel come through the door. And Costel?
Yes, here.
What do we use those 2 formulas for there? 2 to n and 2 to h minus 2. Can you help us out?
Yeah, well, 2 to h minus 2 is finding the amount of usable hosts for subnetting, right?
Right, yeah.
And 2 to the n is just finding the.
Well, before you go to first one, why do we subtract 2?
Because of the first and last essentially cannot be used.
What are those guys called?
The broadcast and
right, that's one.
The default is that.
The first one's called the subnet ID.
Right.
And the last one's called the broadcast, right?
Okay.
And then 2 to the n, that's a little bit rougher, right? What is that about?
Yeah, that one I skipped my mind. I'm not sure.
Okay. William, can you help us out there? Are you out there, William? No. Working our way up. Rudy, what does that 2 to the n stand for? Rudy kind of fell off the system. I saw him come in earlier. Well, Melanie, it's up to you. Melanie, you see that 2 to the n there, right? What does that really mean? How does that help us out with subnetting? Okay, right there. Melanie? Melanie?
Yeah, I'll try to think.
Okay. We talked about 2 to the h minus 2. That h stands for hosts, and we know if we have 5 hosts, then we got 2, 4, 8, 16, 32. We subtract 2, one for the network ID, one for the broadcast ID. We have 30 usable hosts. But then we got another formula out there that says 2 to the n. And what does 2 to the n mean? What does that do for me?
I forgot.
Not quite sure.
Yeah, I'm not quite sure. It's like calculate and then so you're gonna get this one first, and after that you're gonna deduct 2 for the net ID and broadcast. But I forgot what is that called.
Okay. Let's get working our way up here. Michael Esparza.
Isn't it bits borrowed? If it's
Right. The N stands for networks, and but if we borrow 3 bits, we put a 3 in there for that itsy bitsy n. But what's that telling me?
Network ID and broadcast?
No. Well, let's try Majda. I saw you out there, Majda. I know you like to, volunteer your answers. That's good. Majda, so what do you think? What does that 2 to the n mean? Majda, where'd you go? You left me. All right. One more, then I'll tell you. Jose Mendoza. What does that 2 to the n mean? Because that's kind of important too, in this whole networking scheme, this whole subnetting thing.
Is it binary?
No.
Would it be the number of bits used in the network?
It is, but how do I use it?
As a host?
I gotta wait.
Jose, yeah.
Oh, then I don't know actually. Then
Okay, let's say I want to carve that guy up there, that subnet ID that's listed, and I want to have like 3. I have 4. I want to have. Let's say I want to have 5 subnets. Okay, 5, and so I got to get to 5 subnets at least or more. It's okay if I go over, but I can't have less. So I start counting with my fingers. 2. I start with 2. And I remember subnet has 2 syllables. So I start counting with 2, not 1. 1's for binary only. So 2, that doesn't cover 5. 4 doesn't cover 5, but 2, 4, 8, that covers 5, right?
Yeah.
So 2 to the third, that's the number of bits I borrow to get to cover 5 subnets. And that was in the book, so. But anyway, subnet's not always the kind of things you got to keep on going on it. You got to keep on, studying it. So,
Professor, so then that 2n represents the total number of subnets.
well, I want to, in this example, I want to get 5 subnets, right? 5.
Okay,
That's my goal. 5 subnets.
right.
Then how many bits do I borrow to get 5 subnets?
3.
Right. 2, that's not enough. 4, that's not enough. 8, that's plenty, right?
Right.
That's 3 left over. So I put that n in the formula there. 2 to the third power gives me 8. 2 times 2 is 4 times 2 is 8. And so the first one, highlighted in yellow, shows me subnet, and the bottom one kind of is used for hosts. Okay?
Okay.
All right. All right, let's keep on rolling here. Trying to.
Thank you.
Yes.
if we have time towards the end of class, could we do some subnetting like examples for practice?
I was gonna thinking of doing that. Let's grab a few right now. We saw the ones from our book, and actually they're pretty good. And I think probably people forgot about it too. So let's go to our book, which is IP4 addressing. We do the same problems, but I want you to tell me how they actually got solved. Okay? You may remember the answer.
Can I ask, Professor, with subnetting, Is it usually just a lot of memorization, or will you just figure it out eventually?
No, all of a sudden, you keep on doing this, it'll like boom, all of a sudden you get it. And I was reading a book on that because I took Cisco, then I didn't take the certification test till like 4 years later. That was like really dumb, but it is what it is. So, but then I had to learn it all reading books. And then like one of the things I memorized is this chart you can see right here in the bottom, right? I think we can all do 1, 2, 4, 8, 16, 32, 64, 128. But then you have to kind of memorize it going from left to right too. 128, 192, 224, 240, 248, 252, 55, right? So you have to kind of have that memorized, those two formulas memorized, and that's about it though, really. There's not a lot of memorization. Remember, this is arithmetic. It's not really complex math or anything. So starting our way up here working. So Jose, we're going to put you on a spot again here. So what's the prefix length notation for the subnet mask listed? Jose Mendoza. And chapter 6 is kind of short, so we're not shortchanging that chapter. There's much more material in chapter 4, IP4. So we got time to spend here. So Jose, what do you think the answer is? And how'd you get it? More important. I guess most important, are you out there?
Oh, yeah, I'm here.
Okay, great. So what's the prefix length for that?
All right, here, give me a sec.
And while you're thinking about that, I'll tell the group. We know it's at least 24, right? Because there's 8 bits here, 8 bits here, and 8 bits here, right? So number is something, greater than 24 because there's a number here too. So those are all, realistic candidates. And then Jose, what do you think? /20 what?
Would it be
128?
no
92?
127 maybe?
Yeah, it is, right? How do you get that? Well, we got 8, 8, and 8, right, for the first 3. And then we got 27 bits, which means you have 3 left over. 1 bit, 2 bit, 3 bit. So it's 224, right? And that's equal, 224 is equal to 27. So yeah, 27 bits. 27 really means there's 27 ones in the number portion. So we got 8, 8, and 8 with 3 left over. And if I count 3 down here, boom, 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 I get to 224. So that's 27. So they really count as 224. So 888 plus 1, 2, 3 is 27. So there's your answer. Going right up the ladder here. Habiba, good morning. What do you think? 5 choices. That's not fair. I know you're up for it though.
How many relatives addresses are available on IP4 subnet the 26 mask? Okay, if it's 26, would that mean that's like one portion of network portion of the address?
Well, it says valid host addresses, right? Yeah.
Mm-hmm. Just 1 second.
Mm-hmm. No problemo.
Oh, okay. So I think we're gonna use the formula that we used earlier, like 2 to the n. And since we have it's a 26 bit, so it should be 2 to the 6, but that would give us 64. So if we subtract 2 from it, we're gonna get 62.
I believe so, yeah, 62, right? And then, now here's how, what you said, everything you said is true. And this is arithmetic, so there's more than one way to do it, right? So if you have 26 network bits, you have 6 host bits, right? Which is what you said. Then I put my hand up, 2, 4, 8, 16, 32, 64, and I subtract 2, and I get 62. So right, yeah, what you did is good. All right, let's keep on working our way up here. And our next volunteer would be Fernanda, who I don't see today. Okay, Eric, are you out there? No, Eric, huh? All right. Eddie Bermudez, you're you're on the stage here, so help us out.
Wisdom mask would be used if 5 host bits are available.
Right. Now this kind of, don't read too much. I mean, you got to kind of, now if 5 host bits are available, how many network bits are there? That's a good clue. If there's 5 host bits available, how many network bits are there? 32 minus 5 is what?
32 minus 37. I mean, no. And what was it? 22
27, right? 32 minus 5 is 27.
Oh, okay.
So now we kind of broke this out. There's 27 host bits available, right? 27 network bits. And if there's 27 network bits available, what subnet mask do we have?
Would it be the third option?
It would, right? Sure. Yeah, look at, right? We got 8. It says we have 27. We got 8, 8, and 8, right? Then 3 left over. Then we count 3 more in. This is like the 4th octet we're looking at here. 128, 192, 224, right? So it's that number right there. You kind of got to go back and forth like that. You know, if it's, they're talking to you in host, but here you really want network bits, right? So you go 32 minus 5, and then it's not too bad. Daniel Ahmed, you're up.
Yep. All right, a network administrator subnet, the 192.
$64 things each. So, yeah, we just talked about this. 24 to 26, 2 squared is 4, so you have 4 subnets, right? Yeah.
So this is where you use 2 to the n, right?
Right, yeah. That little tiny 2 is an n. Right, exactly, yeah. So, my next one here, that would be Daniel Cervantes, who's not here. Then it would be Castell.
What subnet mask is represented by the /20 notation? All right, let's see. I'm just calculating right now.
Okay.
So for understanding the subnets, you really have to understand arithmetic, right?
Right, arithmetic, not any kind of math, just arithmetic, yeah.
I see. Yeah, because I tried
Think
doing it
that-
just off my head, and that didn't work out.
Let's see. 255, that's 240, that's 0.
Yes, right, how'd you get it?
So it's a 20 notation. There's 8 plus 8 and 4 bits. So I just added 128 plus 64
Right.
plus
Right,
2.
yeah, 4 bits in, right?
Mhm.
So I kind of think of like 4 bits in, that's kind of 240. So 4 is 240. I don't know if that's the right way to memorize, but I kind of like use that as a the checkpoint. So I 16 is, so I got 4 left over. Oh yeah, 4 is 240. So then I would say 240, right? Okay. Chris Holmes, morning.
Yes, hello. Good morning.
Here we go. What statement is true about variable length subnet masking? What do you think?
Well, which statement could be true?
Yeah.
Let's see. Let me think for a minute. That could be. Okay, hold on. The size of subnet may be different depending on the requirement.
Absolutely, right. Yes. So would be the second one. Right. We have remember, like a router to a router, that's only 2 usable hosts in there. But
Yeah.
then we've seen some other where they had like 20 and 30 usable hosts, right? So good. So working our way up here. Mr. Haynes, good
Quick
morning
question
again.
about that. I have a quick question about that.
What?
So whenever you do variable length subnet, so you go from 24 to 25, it creates 2 subnets, right?
Yeah, it depends on where you go to, right? If you go from 24 to 26, though,
It'd be
it
4.
creates 4. Yeah, yeah.
But there's no way it would be like from 24 to 25, you create 4 subnets, right? It's always just 2 or being
Not
split.
that I'm aware of. Not that I'm aware of. Because
Okay.
actually, what you're saying is you're adding 1 more bit, right?
To do the
And that 1 more bit goes into the first spot, which is 128. So you got 2 subnets that are 128 total IP addresses in each, right?
Okay. Gotcha. Makes sense.
Yeah. Let me ask the group this. Can you subnet a subnet?
Yeah.
Yes, you can, right? We do it.
Yes.
That's what this question says.
PLM.
We subnet, right? So that's like a favorite question on the exam. Can you subnet a subnet? Sure you can. So, Mr. Haynes, here we go. And at half past, we're going to go back to chapter 6.
To discover the identify the
Go ahead.
broadcast address of the destination, to identify the host address of the destination host, to identify the network address of the destination network. I will say to identify the host address of the destination host.
No. The whole ending thing was like the router has to determine what the network ID is. So now
Right.
it's on the same network or a different network,
Or
right?
the network.
It's the whole purpose of ANDing. Whole purpose of ANDing. So the answer should be D. And then working our way up here, we have Brian. Okay, Brian, we knew you knew we'd get to you, right? So you need the answers there, Brian, or can you get without them? Huh?
No, sir. No, sir.
No, this is Brian. This is Brian.
Yeah, it says how many usable IP4 addresses are available on the 192.168.1.0/27 network.
Right.
So if it's 27, that means it's borrowing 3 out of the 8. So that means there'd be 5 left over. And then 2 to the 5th power is 32. And then you would subtract 2 from that. So the answer is 30.
Right. I didn't quite follow the first part of that, but I would have went 32 minus 27 is 5. Then I put my fingers up, 2, 4, 8, 16, 32, and then
Minus
subtract 2 like you suggest. We're back to 5, right? Good. Adi, here we are. Okay, what do you think?
Which subnet mask will be used if exactly 4 host bits are available? If I have 4, I need another to balance it off. So if we calculate it, 128 plus 64 plus 32 plus 16. That will give you 240. That's 255, 255, 255, 240.
Right, yeah, right. And I would have looked at that and said, well, 4 bits, 4 is 240, and I would have grabbed it that way. But yeah, you're absolutely right. You know, there's more than one way to do this. So we got time for 1 or 2 more. Rudy, your question here. Oh, Rudy, you got an easy one.
All right. I got this. Which of the following are components of IPv4 address? Pick 2. Okay. This would be. I would say this is the network portion and the. And that would be also, I think, I'm not sure, but the IPv4, it's not the MAC address, so it wouldn't be the physical portion. But I think it would be also the host portion, I'm thinking, or, yeah. Yeah, let So you would use it on a LAN, right? Local area network? Host to host connection, right? Yeah. We used to use at Cricket. We used to use only IPv6 like for our phones. You know, like that's yeah. We used to only use the IPv6 protocol. I knew because on our phone we used to do like the advertisements and stuff for like the company, like through like social medias and stuff. And I noticed they were all like IPv6 because when I looked in the settings, the phone does have IPv6, just like you were saying, also has a MAC address. So I thought that was pretty unique. I was like, what? All the phones got MAC addresses, and they're like little computers, you know? Mhm. That's funny. Event surf. So. Binary, yeah. Mhm. Octet. Hextet. After expenditures, it's more like $10. Dreamcast? Mhm. Yeah, fine. Only multicast? Oh, okay.
However, so if you're like in some kind of test situation, and you see IP version 6, and the answer was broadcast, you know immediately that answer is incorrect.
Yeah.
Look at these a little bit more detail. So remember, these things are gigantic. So that's okay. We're going to use flag 64 in this class. We just cut the thing right in half. So interface ID. It's really the host ID, right? Host ID, but they renamed it. Then the prefix ID is kind of like the network portion. So, so 64 bits here, 64 there. That's 128 bits, right? And then here's one chopped up in half. This one right here. So look at this. It's pretty short, right? That's 128 A, and then everything else is 0. Except we got the colon there, right? So 64 here, this, and then 64 over here. So we can change that 64, that dividing line there, but for this class, and actually, let's go 1, 2, and 3, we just gotta leave it at 64, okay? And, okay, let's keep on going. Yeah, there is kind of subnetting in IP6, but it's much easier, much easier. So keep on going. So far, so good? All right. So we're looking at unicast addresses. Unicast go from point A to point B. And we're going to look at these here. And we got the IP6 unicast address. It's broken down. The global unicast address. That's like your public IP address where you send, you send your router to go from A to B, that kind of place. So you can see, your email. So global unique, instant routable address. And then right up here. And then the other one is link local. That's an entirely new concept for us. So let's have a link local address, which is just good. Now link local, you're probably thinking like, what the heck's a link local, right? Well, that's just your local area network, really. So, but then now they call it link local. Meaning it's only good on your local area network. And that's not routable. Not routable. And it's confined to a single link or local area network. So let's keep on going. Yeah, every IP6 enabled device should have one. And that's a lot of times it's on there by default. So the first two are global unicast and link local. We have other ones here we make keep on going. Alright, so a note about
Some point. Point is that maybe they open them and now they know what's in it. Now they was gonna hit me up now. Fuck. Why does it take a loss now?
I think we'll talk about in this one screen, and then we won't need to see the rest of the class. Let's look at it. So it's kind of like private addresses, but they're used for local addressing the site, the member site, used for devices that never when I took the test, those same guys never even came up, the link local, and this unique local. So maybe it's a little now, I'm not sure. But it also talks about RFC 1918. This is a little more important. Request for comment. If you make a change to the internet, you can't just, tell somebody, hey, call somebody up and say make a change, right? So you go through this formal process to request a change. And what you would submit is something called an RFC, request for comment. And 1918 was the one for private addresses from IP4. And let's take a quick look at that, see if you understand partially. It's a pretty text document, of course, as you might suspect. But let's see if we can, grab some of it anyway. Here we go. you don't go outside the, you don't go to the internet, it's fine. And it says to save, save time and everything like that, right? So motivation, this is how much is done now. It came in, this doesn't say, but
I'm telling you.
February 1996. Well, oh yeah, okay, lower, right here. Yeah, it's staying right there. So remember, we're running out of IP addresses, right? That's like 15 years ago. But the installation of technology worldwide, you know, there's like a real big demand on all these stuff here, right? They're not going to go through all this, but exponential growth, so they're kind of worried, you know, why not stuff here? So let's give the people some private address. They can use the organization only. They won't have to come to us.
Get it check this out.
The regular usable IP address we can use on the internet. And that's what this is all about. So we just go down here a little bit more. It says, yeah, here, like we saw this, right? This 10.0, no, that's private. And 172.16 to 172.31, private. No, class A, class B, and class C, right? And certification question, of course, is everybody knows that 10.0.0 is private. We've been hammering home 192.168.00. Everybody knows that's private. But the 172, that goes from 172.16.00
He left and disappeared.
172.31.65.65. So if you're in a testing situation for certification, that would be the one. Well, I guess in there waiting.
None of those things.
William, hope you aren't waiting long. I may have missed that. Sorry. William, were you waiting long? Okay, if anybody, pardon? Oh, sorry. That's what RFC is, 1918. So just kind of, it's not too long either. I mean, it's like, well, they got advantage of it, right? So, anyway, it's like almost human readable, right? Not like technique wrote and stuff. Let's keep on going. What are you trying to say about technique? But, you know, some of this stuff, like, perhaps you've all read something, right? Like, what's this guy talking about, right? And that's me too. You know, I mean, I don't write that way, but I mean, you know, sometimes you read stuff, I have no idea what this is about. But this is like a human readable format. You know, they made it kind of like, you know, people can actually read it. You know,
It's for the everyman.
huh?
For the everyman.
Everyman, there you go, yeah. Let's him out. And go back to this. But that's where RFC has changed. You can actually see them on the internet, so it's kind of interesting to see that. So that's probably last time we'll see these locals. Let's keep on going. I'll bring it back to the center. Yeah, the arrow was my reminder. Okay, so here's the global unique address. These are the guys that are routed on the internet. So actually, these are the ones being assigned now. The first three bits. Actually, a very small chunk of all available. And here's our this is 64 here. Then right here, 48. And then there's 12 here, so it's subnet ID. And all you do is just pick the subnet ID and you're done. You don't have to do any calculation like we did with that before. That's kind of a nice feature. And let's keep on going here. Okay, good. Okay. So there's a lot of, you know, like, notice the text, right? So read that. Keep on going. Yeah, begins with 2 or 3. I mean, the numbers like staggering.
These guys.
Any human being on Earth right now, they have like over 1 addresses, and there's definitely out there. So it's huge. They went overboard. I read one book that said running out of IP addresses in version 6 is not something we need to worry about in our life. Prefixes signed by the provider, so it's ISP. The varies on the side. We got the standard ID, which is the prefix and the host ID. This is where the host is. Now they call it interface ID. And that's assigned automatically. Interface ID equivalent to the host portion, right? And we're going to keep a /64. We're not going to change it for the 64-bit interface ID. So it's all easy to understand, more or less. So, yeah, okay, let's keep on going. All right, here's our LLA. That's our link local address. The link local address is something used on the local area network only. So you can see in that picture there, the desktop, the PC goes from the PC to the router, and that's it. It stops, right? Or you could have a linked local address between those two routers too. But those are different linked local addresses. So packets with a source or destination LLA cannot be routed. So every enabled network interface must have an LLA, which it does. If you don't configure it, it'll just do the work for you. And then how do you even memorize these? So link locals, and I just kind of remember I fell down working with these things. So FELL. If I see something that starts with FE, then I know it's like a linked local. That's how I kind of memorize it. So you can see there's a lot of things to memorize here, right? So that's my way of doing it, but doesn't mean it's right. Okay, let's keep on going. Global, what was it? What was GUA? Global universe? Global unicast addresses. Okay. Yeah, global unicast addresses and linked local address data configuration. So we want to actually configure these guys. So I don't know if someone wants to come in. No, we're all okay. All right. So this is kind of similar. So they're very similar to their IP4 counterparts, right? Now we're going to use IP version 6 in place of IP. And you think maybe they should have put IP version 4 in there, but they just left it the way it is. So if you see IP by itself, it's generally IP version 4, but IP version 6 is specifically for IP version 6. And here's a command. This we know this, right? IP6 address, and we put our address in there. So here it is, interface gigabit 000, IP version 6 address. Then we put this guy in there, right? No shutdown, exit. So that's like exactly the same as with IP version 4, except you put an IP version 6. And notice you put an IP version 6. Does the router tell you that? No, but you got to know it because you put IP version 6 in there, right? So keep on going. Now you can actually manually, just like with IP version 4, you can do a manual or a dynamic, right? So manual says, use this guy right here. Don't change it, right? Put this guy in here, and then 64, of course, and then it's your default gateway. That number, that last one there, that's like a .1 in IP version 4. So a lot of times the default gateway ends with a .1. It doesn't have to, but a lot of times it does. And I think they kind of did that with packet tracer. It's kind of easier for the system to grade too. I'm not sure though. So, but anyway, if we want to do it automatically, we got this option up here, right? But we're going to say always use this IP address for that location, for that. You always use that IP version 6 address. And yeah, same one here. So that CAD is short for Academy. So now we got something else here, a little twist. DHCP version 6. Well, I kind of get that, right? Dynamic Host Configuration Protocol. That's the guy that assigns addresses automatically. And for version 6, it would be version 6 addresses, right? But we have something new called Slack. And that's another way to assign IP addresses, which we'll look at shortly. So this all should be not too bad so far. So here they're assigning a linked local address. So remember, you can actually have the system do it for you, but you get one of these huge IP6 addresses, or you can assign your own. And recognizable and easy to remember. So use IP version 6, but then notice you have to put this linked local thing in there too, right? So the system knows it's linked local. So IP version 6, there's our address. We're gonna give it a short one, call it link local, no shutdown and exit. So yeah, it's gotta be, each link is launched unique on that link. So different subnets could have the same linked local address because they don't talk to each other over the internet, right? So, but it's a lot easier to identify this than some big long IP6 version address. All right, boom. Dynamic addressing. All right, here's where you earn your pay. Here's where you earn your pay. Dynamic addressing for IP6 global unicast addresses. So remember now, we had this IP6. We could use DHCP to create our addresses, right? Well, we don't need to use that in IP version 6. And there's 3 methods to get an IP6 address in IP6. And they're highlighted there in yellow. But yeah, we might do solicitation and then advertisement. So solicit, you're kind of asking, then advertisement, you're coming back and you're talking back and forth. So router solicitation, router advertisement. So solicitation is first, then responds what comes back. So this ICMP is a way to get the addresses is what we're going to use. So, and yeah, you're going to get the network prefix, default gateway, DNS addresses, and so forth. So let's look at the 3 methods. Now this I got from from Cisco 3 book because the way our book explained it, at least to me, is a little bit hard to follow. So there's dynamic global unit address assignment, global unicast, global unicast, right? Global unicast address. There's 2 there's stateless and there's stateful. So stateless means there's no record kept. Okay, here's your address. Do what you want. And stateful says we will keep records, right? So now this says that should be of. Okay. So anyway, so we'll look at Slack with DHCP server is stateless, and DHCP server stateful. So let's look at these kind of in detail before we go on. No device is tracking the assignments of IP6 addresses. That's kind of weird, right? And then stateful is tracking the assignment of IP addresses. So router sends the advertisement. Boy, this is spelled wrong too, right? Providing all IP6 address information. And then host uses all the information for their own global unicast address. So stateless DHCP6. You got to read this more than once to understand it. So use the RA information, router advertisement, right? RA, a router advertisement. Create their own global unicast address. And then the other one here, and I believe this is the one that's most like what we have now. So let's look at these, okay? More detail. So here's method one, Slack. Allows the device to configure an IP address with no DHCP version 6. What the heck, right? So stateless means there's no server maintains network address information. So I figure like, stateless, it does less paperwork, so to speak, so it doesn't keep any records. Stateful, I think something like very prim and proper, all kind of records being kept. So stateless is like no records. Yeah, so there's ways to connect, there's ways to do this too, either by EUI 64, which we'll look at in a short time, or just a random number configure. So here's your prefix right here, and then this guy down here is configured. Well, this one actually configured through EUI 64. This has a FE in there, and we'll see what that means shortly. But let's keep on going. Okay. So that was method one, right? That was this guy here, Slack only. Now, method two is Slack with DHCP server, I believe. Yeah. Slack with stateless DHCP. So the router advertisement says use Slack and stateless, and Slack creates its own IP6 global unicast address. That's pretty cool. The router LLA, leak local address, is a default gateway, right? So our default gateway is our IP address of our gateway. And that's all. So the link log from now on in IP version 6, the default gateway in IP6 will be a linked local address because it's on that linked local, the local area network. So keep on going. So yeah, then it's got to go other way. Stateless DHCP server to obtain other information like the DNS server, right, and the domain name. So, so this guy here, he sends out a message. It comes back, and then the DHCP. What does that say? DHCP version 6. Read that. SO. Oh, solicit.
Solicit, yeah.
Solicit. Okay. All right. Thanks. You guys are too young, but Mr. Norval has this big magnifying glass here just in case something's like really hard to read. So, but anyway, let's keep on going. And we're going to review this again next time. So method 3. So let's look at that. That's this guy here, right? That's a stateful one. It's the prim and proper one. All configuration except the default gateway address. We know what that is. That's a linked local address, right? So let's keep on going. So method 3. This is most similar to DHCP for version 4. Automatically receives the global unicast address from, and the address of DNS servers from a stateful server. Stateful and maintains a list of everything it hands out. So the router LLA is used for default gateway address, and then server gets the GUA DNS server address and other stuff from the DHCP server. So stateful server, suggest devices use the following global unicast, global GUA DNS and domain name. They suggest it. So let's keep on going. All right, so here's that crazy EUI 64 process. So when the RMS is either slack or slack, that's one of the first two, right? Let's just take let's go back there real quick. I think you already saw that, but what's one of these first two? It's stateless, right? Stateless. So we can use EUI 64. Right. And that's right here. So what happens is, now the MAC address is 48 characters, right? But the interface ID is 64. So they're not the same size. So we got a problem there, right? So we have to insert something into the MAC address to make it 64 characters long, so the system will have 64 characters to deal with. So here it says the interface ID can be used as EUI 64 process or a randomly generated 64-bit number. Let's see what that's about. And EUI stands for Extended Unique Identifier. And what we're going to do, we're going to take, now remember, the 48-bit MAC is too short for our IP6 address because that last half is 64. So we got to insert some stuff in there to make it 64 also. So what they put in there is FFFE. And I'm looking all over the place. Why FFFE? And I did a search on the internet pretty good, but I just couldn't find out. So, but anyway, it is what it is. So what they do is they take that MAC address and boom, right down the middle, they cut it in half. And then they put FFFE in there. And then they flip one of the bits here, like the 7th bit and the second, the 7th bit, they flip that too. And then that becomes our EUI 64 interface ID. We got a good video on this coming up here. Let's keep on going. Yeah, the 7th bit is reversed from 0 to 1, or if it's already 1, then it comes back to 0. So let's keep on going. Here's that FFFE, that's hex, right in the middle of our MAC address. So right here, yeah, between 7 and 7, right? Yeah, between 47 and 75, that's where we put that thing. All right, let's keep on going. All right, this is a good video here. And he talks about how they actually insert that. We've already seen it, but let's take a quick peek here. And it's only 5 minutes. And I gotta get my pointer here. Okay, here we go. It's Kevin Wallace. Now he's the guy who wrote those videos on the subnetting, which I kind of encourage you to take under course resources. There's like the regular subnetting for IP4 and advanced subnetting for IP4. And I think that'll really help you with subnetting for IP version 4. So if you do take the certification test for Cisco, that's certainly one subject that will be on there, okay? Here we go. What's that?
Okay, Kelly, I see you. After years of swiping right on human garbage, looks like you found the man of your dreams. But there's just one thing. To help ease the administrative burden of manually configuring an IP version 6 address for the link local address, for the unicast address on a router interface, we could use the EUI 64 address. That's the Extended Unique Identifier. What we're doing is taking the MAC address on a router's interface or another IPv6 speaking device and using that as the basis for creating the interface ID portion of an IP version 6 address. If you recall, the basic format of an IP version 6 address, the last 64 bits, were referred to as the interface ID. What we can do, again, as a time saver, is to take that MAC address and use that for the interface ID, but we've got a challenge. The challenge is the MAC address, it's only 48 bits long. We need a 64-bit interface ID. What can we do? That's what this EUI64 standard is all about. It tells us how to manipulate that MAC address to convert it into a corresponding 64-bit address that can be used as the interface ID in something like the link local IP address on a router interface. Or when we talk about auto configuration, we can dynamically learn from the network what our globally unique network address is and then just append to that this EUI64 address. To illustrate how we take a 48-bit MAC address and convert it into a 64-bit interface ID, let's go through an example together. Let's say that R1 on screen has a fast Ethernet 0/0 interface, and its MAC address is 0015.2BE4.9B60. And we want to use that MAC address as the basis for the link local address. Let's go through the steps together. In the first step, we're going to take those 48 bits in that MAC address and we're going to split it down the middle. Let's take that MAC address and divide it up into two different chunks, 24 bits each. Now that we've done that, we're going to insert in the middle FFFE. We stick that in the middle, and now we have a 64-bit address. We're not done just yet, though. When we're writing out our IP version 6 addresses, typically we do not use a dot as the delimiter. Instead, we use a colon as the delimiter, so let's make that change. And something else we need to do something with the 7th bit in these 64 bits. To do that, we want to take the first couple of hexadecimal digits, 00 in our case, and we want to convert those two hexadecimal digits, which would be 8 bits total, we want to convert that into binary. Well, obviously 00 in hex is going to be all zeros in binary. What we want to do, though, is flip the 7th bit. In other words, if the 7th bit is a 0, let's change it to a 1. If it's a 1, let's change it to a 0. By the way, why are we focusing in on the 7th bit? Well, the 7th bit in a 48-bit MAC address, that's referred to as the UL bit. That bit is set to a 0 if we're saying the MAC address is universally unique, and we set it to a 1 if it's locally unique. Typically, that 7th bit is going to be a 0, as it is here, and we're going to flip it. We're going to change it to a 1. Now that we've made that flip of the 7th bit, we want to convert these 8 bits back into a couple of hexadecimal numbers, and now we've reassembled these 64 bits. This is our EUI64 address, 0215:2BFF:FEE4:9B60. We can now use this EUI64 address as one example to create our link local address. Do you remember the format of a link local address? It began with FE80::, and we're just going to stick this EUI64 address on the end of that. This means our link local address is FE80::. We're going to leave off that leading 0 in the EUI64 address. Don't need to write that in our hexadecimal field. So we've got FE80::215:2BFF:/FEE4:9B60. That's one use of the EUI64 address. We've used our MAC address, converted it into this EUI64 format, and then used that to construct the link local address for this router interface.
So I've got my essay written, and I've been working on it for about a week. So now I'm going to show you how I use Grammarly to edit. Okay, so here's my essay, and I'm going to click through.
Okay, any questions on that? kind of a bizarre process, right? So that's certainly out there if you're looking at it again, if you like. Let's keep on going. We got to get some more stuff in here. So, yeah, okay. Oh, there it is. Yeah, I did look. I try and find that. Yeah, I put this in here. YFFFE, reserve value. Okay, which equipment manufacturers cannot include in a real EUI address assignment. In other words, any address having FFFE can be recognized using the EUI 48 or MAC address. So, all right, let's just take a quick peek here. I did find it out. I forgot. Well, the point was it's something that can't be used, and it's used. You know, there's not really. You know, it's not. It's something I added, but it's not really something need to worry about. Just kind of like YFFFE, and I guess that's the answer there. So, and I just kind of cut and paste this thing right here. So, but there's another explanation of the same process. So let's keep on going. All right. So using that EUI 64 deal where you kind of cut the thing in half and go FFFE in the middle, or you can just use a randomly generated ID instead of EUI 64. And Windows actually uses a randomly generated interface ID instead of EUI 64. So can anybody think a reason why they might not want to use EUI 64?
It's easy to find out the MAC address of your computer.
Yeah, you can like reverse engineer it, right? And then like anything you do on the internet can be tracked in a sense, right? So that's why yeah, it's a good answer. Yeah, exactly right. So now Windows uses randomly generated ID instead of the EUI 64. So anyway, you're right. So here's the real long linked local address, but we can actually shorten it up if we wanted to, and we'll see how to do that. So our default gateway, you know, ends in .1. So let's keep on going. Dynamic addressing for IP6 linked local addresses. And we got time. It's a good deal. Okay, so like we said earlier, all the IP6 version 6 interfaces must have this IP version 6 LLA. And you can actually go in there and assign it. And I think if you don't assign it, it'll assign it for you. Like you like remember that screen where we saw the IP version 6 in there, that real long address? Well, they would have the system would have put in a linked local address too, because you didn't do it. So it kind of covers for you. Question? No? Okay. Yes, FE80. Remember FE fell for linked local interface ID. So here's your linked local, right? Your interface ID. So keep on going. Okay. So operating systems like Windows use the same method for both a Slack created and a dynamically assigned LLA. So notice FFFE in both addresses, right? Those are that cut it in half deal, which is the EUI 64. But down here, we got the random generated number, and you really can't see the FFFE in there. So there's no way to track it back like I think that's what Michael said earlier. So, but anyway, let's keep on going. Yeah, Cisco routers automatically create that IP version 6 whenever a GUA is assigned to the interface. So routers do use the EUI 64 for all LLAs. So, example of a dynamically configured on the G00 interface of R1. So, this integrated services router is what ISR stands for. And then here's our MAC address, right? 7079B392. Okay, so that's not been changed since it came out of the factory. This is what it came out as a factory. It's not been changed. And then show, we can see the link local, and it's got the the second bit is flipped, right? From 0 to 2. B3, 92, 3640. We had the FE in there. So let's keep on going. Packet tracer. Multicast address. Okay, a little bit more here. Okay, let's keep on going. Multicast addresses. So multicast are FF00, and there's two types. There's well-known and solicited mode. So they're only destination addresses, not on source addresses. So let's look at that a little closer. So you should know that multicast is FF. And I don't know why this sticks in my mind, but you see that M there, that M? It kind of looks like an FF, right? Not really, but I guess to me it did. So it's kind of, I can remember that FF is like multicast. Mr. Norval does not try and hard code memory of this stuff in my mind at all. I like to use links if I can. So there's two kind of IP6 multicast groups. All nodes, that goes to everybody, and then all routers, all router updates. So there's two kind, FF02, with a 2, and then all nodes is a 1, routers is a 2. Let's keep on going. So yeah, that's kind of like our all interfaces on the link or network. So, and then it goes to all routers. So, and there's other commands as we get into this that like with like routing protocols, you want to send it just to all routers, not everybody. So that's why that's used there. So let's keep on going. The node, right, right here. So similar to all nodes, multicast address, right? So here's our destination MAC and our destination IP6 solicited node. Separate, just like before with the, yeah, here's the deal though. Ethernet NIC can filter the frame by examining the destination MAC address without sending to the IP6 process to see if the device is intended for that target. So like if it doesn't belong to me, it's going to reject it sooner, which is good. Excuse me. So we'll kind of review this next time too. So examines the destination MAC address. If it's not him, it just dumps it. So let's keep on going. So here's a multicast thing. Right? It's going to FF00::A, which is way up here. So it's going to these guys, but not to this guy. And we want that because that's, we want to send our traffic out efficiently. Let's keep on going. Subnet and IP version 6 network. You guys up for this? Actually, it's not that bad. We'll look at one more screen and call it a day. So remember, you got 128 bits here. And the last 4 is the interface ID. The first 3 is the routing prefix, and then the subnet ID is right here. And actually, all you do is just pick out a number. That's your subnet ID. None of this, all that work we went through. So, but we're going to stop right here. I'll be in the room another half hour if you have any questions. Otherwise, we'll see you in 45 hours?
Thank you, sir.
All right,
Thank
thanks
you,
a lot.
Professor. Have a good one.
Yeah.
Thanks so much, sir.
Thank you.
Bye.
Thank you, Professor. Have a nice one.
All right, thank you.
Yeah, Professor, I think I have to work on this for a little bit myself because this guy's computer is kind of a little broken, so I got to kind of fix it before I ask anybody
Yeah.
to solve that problem.
Mm-hmm.
But I appreciate your help. I'll let you know by
I-
Thursday.
Yeah, I can't add anything to that, Daniel. I just don't know.
Yeah, I don't really know
So-
either. I guess that it's good practice for tech support.
I would check the internet though. It looks like we have some good leads there, right?
Yeah, it does. You said look up radio frequencies on laptops. Maybe that probably would give me a lot more further.
Exactly. Yeah. Mm-hmm.
All right. Well, thank you for the help, Professor. Yeah, have a nice day.
All right. Very good. Have a nice one. Thank you.
Bye.
Bye-bye. Rudy, you're still there. Just what it is.